Welcome, everybody. This is part 2 of Taking the Regents with Segelke. This, of course, is the second part of the June 2016 Regents, so let's hop right in. Resuming with number 20, entropy is a measure of, well, just by definition, disorder. High entropy means high disorder in a system. For example, gases have extremely high disorder, whereas solids have extremely low disorder. High entropy, low entropy. Which element has atoms that can bond with each other to form ring, chain, and network structures? That has to be carbon. Why? If you remember Mr. Russo's honk, that tells us the number of bonds that each of these elements have to form. H is 1, O is 2, N is 3, and carbon is 4. That means carbon always has to form 4 bonds. So that allows it to form these long chains, or branch structures, or even structures that pull back on themselves and form rings, like so. So only carbon can do that. Number 22, what is the number of electrons shared in the multiple carbon-carbon bond in one molecule of pentyne? Well, whenever you're dealing with hydrocarbons, I recommend you go directly to table Q. Pentyne is an alkyne, and if you know that all alkynes have to have a triple bond, that's the multiple bond that they're talking about. Since it's a triple bond, be careful. The answer is not 3, because they're not asking about the number of bonds, but the number of electrons. We have 3 bonds, and we know that there are 2 electrons per bond. That means 6. Choice number 1. Number 23, butanal, butanone, and diethyl ether have different properties because the molecules of each compound differ in there. Well, in order to talk about these effectively, why don't we now go to table R, where these compounds are all listed. Recall that butanal, look at the table. If you end in al, you're an aldehyde, and you have this functional group. If you're an ether, you have this functional group. If you are one, you are a ketone, and you have this functional group. Different functional groups mean different physical and chemical properties. I think I got cut off there. We said different functional groups means different physical and chemical properties. Question 24, what occurs when a magnesium atom becomes a magnesium ion? Well, what does it mean to be an atom? It means that you have a charge of 0, an oxidation state of 0. All atoms are neutral. The magnesium ion, well, you can look it up. If you go and you look up magnesium on the reference periodic table, you see that it's a positive 2 charge. So as this happens, I am going from a lower to a higher oxidation state. And remember, if we finish this half reaction, we have to put 2 electrons on the product side, showing us that we lose electrons. When that happens in oxidation, remember oil rig, oxidation is losing. You might even like oily rig, oxidation is losing electrons. So since we know that the oxidation number increases, we know that it's oxidation, and therefore we know electrons are lost. Number 25, energy is required to produce a chemical change during. Well, if they're asking about the chemical change, it must mean that the others are potentially physical changes. So are the others all physical changes? Well, notice here, boiling and melting are both phase changes, and phase changes are our favorite physical changes, so it can't be those. Chromatography is a method by which you can physically separate a mixture into its components. So these are all physical changes or entail physical changes. That leaves us electrolysis. Remember, in an electrochemical cell, you have to supply electricity to an electrochemical cell, and that's going to drive a chemical reaction. RXN is a way of abbreviating reaction. Just a fun fact for you. So it has to be electrolysis. Number 26, the reaction of an Arrhenius acid with an Arrhenius base produces water and, well, to answer that question, Our favorite areneous acid on table K is HCl. And let's choose our favorite areneous base from table K is our acid. Go to table L for the base, and NaOH is our favorite base. Now it tells us in the question that we produce water. Well, where does the water come from? Well, my friends, it comes from the hydroxide of the base with the H of the water. That leaves us with NaCl. Oh my goodness, NaCl, that's salt. Choice 1. One acid-base theory defines an acid as, well, just by definition, it's an H donor. Now, why is that? Well, look at our favorite acid, HCl. When you put that into water, it's going to get rid, it's going to release a hydrogen ion, also known as a proton. So that's we're always reminded by the very fact that every acid contains an H, and because it contains an H, it will lose an H plus donor. Number 28, which phrase describes the decay modes and half-lives of K37 and K42? Well, you need to go to table N to answer this question. So let's go there right now. Here we are. If you notice, I circled the two isotopes in question. They're side by side. If you notice, one has a positron, the other has a beta particle as part of its decay, and they have different half-lives. So with that information, the answer to 28 must be different decay modes and different half-lives. Choice number 3. Number 29, which particle has a mass that is approximately equal to the mass of a proton? Well, if you're unsure about this, you can simply go to table O, and it becomes a very easy question. Let's go. Here's a proton, and we're reminded here, if we remember, of course, the top number is the mass. So I'm just going to look at these other emissions that, and we're going to see which one has also a top number of 1. The only one that has that is a neutron. So that answers our question. So in 29, the answer has to be a neutron. Number 30, which change occurs during a nuclear fission reaction? Well, among other things, guys, where does all of the energy come from in both fission and fusion? In other words, what do they both have in common? Well, they have the famous Einstein equation of E equals mc squared, which says the following, that a small amount of mass within the nuclei in question turn into a corresponding amount of energy. So very simply, matter is converted into energy. Question 31, which notations represent hydrogen isotopes? I wanted to remind you that to be isotopes, you have to have the same atomic number, which is the bottom number, but different mass numbers, the top number. The only one that fits the bill is 1. Notice 1 and 1, same atomic number, the top 1, top 2, different mass numbers. Number 32 is a weighted average question. Naturally occurring gallium is a mixture of isotopes that contain this percentage of this isotope with this mass, and this percentage of this isotope with that mass, which numerical setup can be used to determine the atomic mass of the naturally occurring gallium. Remember, atomic mass is a weighted average. Well, remember what I told you. Sadly, this formula here for weighted average is not on table T. You have to remember how to do it. I said here the way they presented it makes it a little bit more difficult for us. But remember, if I take the percentage of isotope 1 and multiply it by its mass, and then I add that to the percentage of isotope 2 times its mass, I'm going to get a value that's 100 times too big, so I have to divide that by 100%. So that's a little bit confusing, but again, I'm just trying to show you how to connect it within the problem. So this percentage is 60.11, isotope number 1. It is a mass of 68.93. And to that, I'm going to add the mass of isotope 2, which is 70.91, or 92, sorry. And its percentage is 39.89. Now, if you're if you're not careful in this problem, you're going to go and say, oh, it has to be choice 4. But it's not. Notice, everything is where it's supposed to be, just as I wrote over here, except it's not divided by 100%. So it can't be number 4. So then what's the answer? Well, if you notice here, choice 3 is the result when you divide the percentages by 100%. Notice here, I took that 60.11% and divided it by 100. And in the next term, I took the 39.89%, divided it by 100, got 0.3989. So be careful, it's choice 3. It's not an infrequent question. Question 33, which list of symbols represents non-metals only? Well, notice what I did. I made a little sketch of the staircase and the neighboring elements from the periodic table. Remember, the staircase indicates where we find the divide between metals and non-metals. And of course, those blue elements on the staircase are ones that we call metalloids. Remember, Al and PO are also on the staircase, but they're special, they're metals. I put all of the non-metals in green. They're to the right of the staircase. So in other words, I can only have a green element in my list. Well, the only one that contains all green elements is choice 4, phosphorus, sulfur, and chlorine. Remember, the metals are the bulk. 2/3 of elements are metals, and those are found to the left of the staircase on your reference table. Question 34. This formula, XSO4, they would like to know what the symbol X could represent, and they give you 3 elements. Well, I mean, it might jump out at you, first of all, it can't be 2, because argon is from group 18, and those never react. In other words, they never wind up combined in the form of compounds. But how am I supposed to know whether it's the metal aluminum, magnesium, or Na? Any of which could be this, because the metal always goes first. Well, treat it like an algebra problem. We do not know what X is. So we're going to say that its oxidation number is X. Now, sulfate, if I go to table E, I'm going to see that sulfate overall has a -2 charge. And recall that the sum of the positive and negative oxidation states must be 0. Therefore, this must be +2. The only element that has an oxidation state of +2 is magnesium +2. Number 35, what is the chemical formula for lead 4 oxide? Well, start from the symbols. Lead is Pb. You can go to table S to find that. Oxide is O. Now, the Roman numeral 4 is lead's way of announcing to you that its charge is 4. There are not 4 leads. Each lead has a +4 charge. What is the charge on oxide? Well, you probably have memorized it by now, but if you forget, go to your periodic table, look up oxygen, it's a -2. So now we swap, drop in, we reduce. We bring the 2 down here. We bring the 4 down there. We have Pb2O4, which we then reduce to Pb1O2, choice number 1. Number 36, which statement describes the general trends in electronegativity and radius as the elements in period 2 are considered in order from left to right? Well, if you notice what I did below, I went to the table S, and I just chose 2 elements side by side in period 2 to compare. I just looked up their radii, and I looked up their electronegativity. As you see that there is an increase in electronegativity, but there's a decrease in radius, which is going to be choice number 3. And with that question, guys, we're going to bring part 2 to an end. Please stay tuned for part 3, which will be present up online shortly. Thank you so much, and bye-bye.